This section looks at the reading for this unit, the paper by John Blitz and Patrick Livengood, that tries to answer the question of why are some mounds bigger than others. On the left we see Monk's Mound, the largest mound in the Mississippian world, and on the right, Mound A at Etowah in Georgia. Why is one so much larger than the other? What conclusions can we draw from differences in mound sizes both within and between communities? In their introduction, Blitz and Livengood review some of the previous research and suggest there have been two different interpretations as to why some mounds are bigger than others. One interpretation is that the mounds vary in size based upon the length of their use. The longer a mound was in use, the larger it would become. The other basic interpretation is that the differences in the sizes of the mounds reflect differences in chiefly power between different communities, with those sites that have larger mounds were the centers of greater power. So how can we assess these interpretations and determine which better explains the differences in mound size? Blitz and Livengood suggest that we have data on hand that should allow us to adequately assess the importance of the length of use in the variation in sizes of mounds. First, Blitz and Livengood compiled data from 35 excavated mounds, where they were able to collect information on the size of the mounds, the length of time that they were in use, and the number of construction stages that contributed to their final dimensions. They created a mound volume index to standardize the information they had about the size of the mounds, and they found that the duration of use had a mean, the average of all 35 sites, of 183 years of use, but it also had a median, the point within the very middle of the distribution of all values, of about 150 years. So the mean and median are relatively close. Construction stages were found to have occurred every 25 to 50 years, suggesting that mound building was likely a once-in-a-lifetime occurrence in most communities. Some proponents of the chiefly power interpretation have suggested that the labor burdens placed upon community members building these mounds could have been fairly great, but if they were only every 25 to 50 years, perhaps only once in the lifetime of most community members, it would seem that it might not have been a large labor burden upon the community. Blitz and Livengood used histograms or bar charts to visually represent the distribution of values for a variable and to explore the variation across the population of cases. In each of these histograms, the x-axis indicates the value for a particular variable, and then the y-axis indicates the number of cases in the sample that equal this value. They are looking to see how the values are distributed across the entire population, whether they have what is called a normal distribution, and this is normal in the sense of statistics, that you have the distribution centered upon the mean and distributed equally greater than or less than the mean. The sort of classic bell-shaped curve as we see in the furthest right graph, the one that looks at the relationship of duration in years to the length of occupation. The distribution of other variables, like the number of construction stages and the mound volume index, is skewed towards one end of the distribution over the others. In both of these cases, it seems that there are more smaller mounds and more mounds with fewer construction stages than there are really large mounds and mounds with multiple construction stages. So those really large mounds and the mounds with many construction stages are sort of atypical of the entire distribution of mounds. Blitz and Livengood also use scatter plots to assess the relationship between the values of two different variables. In both of these graphs, the x-axis is duration in years of mound use, and on the left-hand side it is plotted against mound volume index, and in the right-hand side it's plotted versus the number of stages. Linear regression uses math in order to calculate the slope of a line that best fits the distribution of points in a scatter plot. This slope will range from -1 to +1. 0 is a perfectly horizontal line and indicates little relationship between the variables. The closer the value is to +1 or -1, the greater the strength of relationship between the two variables is. On the right-hand side, there is a close relationship between the duration that a mound is used and the number of stages in its construction. The longer a mound is used, the more likely it is to have multiple stages. We can see a near perfect correlation between them as the slope is close to +1. However, you have a much lower slope and less direct correlation between the duration of use and the size of mounds. Blitz and Livengood then went further to use a technique called Spearman's rank order correlation, which measures the statistical dependence between two variables, or how much does the variation in one variable, variation in A, result from corresponding variation in another variable, say variable B. So how much does the variation in mound size result from variation in length of use or in the number of stages? So they suggest, based upon these analyses, that 27% of the variation in the size of mounds results from the number of stages that led to its final form. 11% of the remaining variation is the result of the length of time that the mound was in use. So therefore, 62% of all of the variation in mound size results from factors other than the length of time they were in use or the number of stages, perhaps more intangible variables to measure, like chiefly power and the charisma of the chief. So Blitz and Livengood discovered that the length of use and the number of stages accounts for 38% of variation in the size of mounds. And a greater amount of variation is based upon perhaps a less easily defined and measured variable, the power of chiefs. However, they also don't consider another possibility. How much does the function of the mound, the social and political context of the use of the mound, contribute to its variation? And this, like chiefly power, is not as easy to measure as size or length of use or number of stages. But thinking of chiefly power, how might you measure differences in chiefly power between different mound centers? One means might be looking at the number and the quality of the types of offerings placed within these mounds. Just as a larger mound might indicate a more powerful chief, a mound with more copper, shell, or other high-valued objects placed within it may suggest a chief with greater wealth and access to power than other chiefs who don't have as many of these materials deposited within the mounds. This relative difference in sizes of mounds is important when looking at the distribution of mounds on the landscape and trying to understand the relationships between different mound centers. Now, Cahokia, which has the largest mound as well as the most mounds of any site in the entire eastern United States, and also of any site within its immediate area, could be seen as being centrally located and therefore at the center of a political system of mound-based communities. The settlement pattern suggests that Cahokia was a regional civic and ceremonial center that integrated all of the other communities in the region. This is a basic principle of geographic analysis of city size and the nature of political and economic relationships between them, and we can look at Arizona as an example. Here I have plotted many of the cities in Arizona based upon their relative size. We have Phoenix at the center, the largest community in Arizona, with other communities like Tucson to the southeast, not as large, but larger than others, and then communities like Prescott and Flagstaff, and the next tier down, and then smaller communities like Yuma, Gila Bend, Casa Grande, Williams, Holbrook, Page, Kingman, at the lower end of the distribution. And in Arizona, the largest and most centrally situated city, Phoenix, is the political and economic capital of the territory. It drives political activities, it drives economic activities, and it is located centrally within the state. So the classic model of Cahokia is of a highly integrated chiefdom with a paramount mound center, Cahokia, at the top of this sort of tiered structure of mound sites of different sizes. You then have second-line mound centers that have large mounds, but not as big as Cahokia, or not as many. And then you have third-line mound centers that have even smaller mounds at them, perhaps only a single mound. And then below them, smaller villages, hamlets, and farmsteads lacking in mounds. So this figure shows how directives, orders coming out from the chief down to his subordinates at the second line mound centers, who would then relay these communications down to the lower tiers of organization. And then the movement of tribute, people's labors, agricultural surplus, moving up from these nodal villages, hamlets, and farmsteads where the producers of these products actually lived, moving up through the different levels of the system in order to be collected at the paramount mound center of Cahokia, and possibly redistributed back through the same chain of command during times of need. But there's an alternate model that Cahokia maybe at some times could have directly controlled all of these sites within this area, but at other times perhaps those chiefs at second line mound centers considered themselves not subordinate to Cahokia and attempted to assert their independence. Maybe in some cases they would take directives and pass tribute on, but at other times they might resist direction and refuse to pass tribute on, as they are striving to elevate themselves and expand their own territory, perhaps at the expense of the chiefs at Cahokia, to whom they have in the past been supportive of. And this figure shows that there would be zones of tension between the leaders at the paramount mound center and these second line mound centers, who could be seen as potential emerging competitors for the chiefs at the paramount mound center. And warfare between communities was a means of expressing these tensions, as a means of trying to extend or consolidate the control of chiefs over certain territories. So what to remember? Blitz and Livengood asked, why are some mounds larger than others? Were the differences in size related to either the length of time that a mound was in use, or the political power of the chief or chiefs responsible for constructing the mound? They used data on size and length of use from 35 mounds to assess the relationships between these variables, and found that the duration of use, the length of time, the number of stages, accounts for only 38% of the variation in size, that chiefly power or some other variables account for the remaining variation. On a landscape scale, the spatial relationships between larger and smaller mound sites suggest integrated chiefdoms, where the largest sites act as regional centers, bringing together the smaller communities that surround them. However, the power at these central sites may have fluctuated, and chiefs at smaller sites may have had some independence, and maybe even some had aspirations of expanding their own power at the expense of their overlords, leading to conflict and potentially warfare, as chiefs tried to consolidate their control over certain territories, and in some cases expand their control to neighboring territories.